Welcome you all for CISC Architecture. In the previous session, we discussed about RISC architecture. Now we are going to discuss about CISC architecture. What is a CISC first? It is a complex instruction set of computer CISC. It is pronounced as CISC. It is a microprocessor instruction set architecture, and in which each instruction can execute several low-level operations such as load from memory, an arithmetic operation, and a memory store, all in a single instruction. Hardware is always faster than software, the main idea of CISC. Therefore, one should make a powerful instruction set which provides programmers with assembly instructions to do a lot with short programs. So the primary goal of the CISC is to complete a task in few lines of assembly instruction as possible. The memory in those days was expensive. It was bigger program, more storage, more memory, and hence needed to reduce the number of instructions per program. The number of instructions are reduced by having multiple operations with a single instruction. Multiple operations lead to many different kinds of instructions that access memory, in turn making instruction length variable and fetch, decode, execute. Time unpredictable, making it more complex. Thus, hardware handles the complexity. The philosophy of CISC, it uses microcode. It is used a simplified microcode instruction set to control the data path logic. This type of implementation is known as microprogrammed implementation. Here we have two sets like build rich instruction sets and build high level instruction sets. So build rich instruction sets, it consequences of using a microprogrammed design is that designers could build more functionality into each instruction. Build high level instruction sets, the logical next step was to build instruction sets with map directly from high level languages. So the characteristics of CISC design, it is register to register, register to memory, and memory to register commands. It uses multiple addressing modes. The variable length instructions where the length often varies according to the addressing mode. The instructions which require multiple clock cycles to execute. So this is the architecture of CISC, whereas CISC versus RISC. So this is the main memory which consists of 1 to 1 or 64 or any totally of about 24 locations, right? And the general purpose registers like A, B, C, D, E, F, and also arithmetic logic unit, execution unit, etc. So this is the main architecture of CISC where it versus our RISC, right? So the multiplication, consider the operation of multiplication. Let us say we want to find the product of two numbers, one stored in location 2:3 and another stored in location 5:2, and then store the product back in the location 2:3. That is, the memory of 3 is lesser than or equal to memory of 2 multiplied by memory of 2,3. So the approach of CISC is, it is a particular task. Processor would come prepared with specific instructions. We call it as mult AB. When executed, this instruction loads the two values into separate registers, multiplies the operands in the execution unit, and then stores the product in the appropriate register. Entire task of multiplying two numbers can be completed with one instruction, and it is known as a complex instruction. It closely resembles a command in higher level language, identical to the C statement. Okay. So this RISC approach in CISC processes only use simple instructions that can be executed within one clock cycle. Okay. This is the comparison between CISC and RISC. So the primary goal is to complete a task in a few lines of assembly as possible is CISC, and it is to speed up the individual instructions, whereas in CISC emphasizes on hardware and in CISC emphasizes on software. Here multi-clock and here single clock, and here memory to memory, load and store, here register to register. So here small code sizes and here large code sizes. This is the main difference between the CISC and RISC. So this is the architecture. Which one is better? With this comparison we can say which one is best. This is the performance equation calculated. Time by program is equal to time by cycle into cycles by instruction into instruction by program. This is RISC and this is CISC. Cycles by instruction is RISC and instruction by program is CISC. Here we can say which one is best. So no big difference now. RISC and CISC architecture are becoming more and more alike. Many of today's RISC chips support just as many instructions as yesterday's CISC supports. So simply we can say RISC and CISC are growing to each other, right? So these are the recent developments and future hopes of EPIC, that is our RISC and CISC. The biggest threat for CISC and RISC might not be each other, but a new technology called EPIC, that is explicitly parallel instruction computing, is created, right? So these are all about our CISC architecture. So in the next class we will discuss about memory devices. Thank you.